là ça marche. J'ai dit OK, mais je me suis pas entendu.
Vas-y.
Hello, welcome back everyone. So we are. So thanks for being here for the last afternoon. So we have now a 15-minute session where we will award prizes. So there is first a prize for a data challenge and then prizes for posters.
So good afternoon, everyone. I'm Aurore Archambault, and I'm pleased to be here for this session because I co-organized the datathon with Angelina Roche and Julien Cornebise for the young group of the French Statistical Society. This contest was only for young people, and the award was a free registration to useR. To interest them more, we decided to propose to analyze some and quite a few key indicators related to nutrition, population dynamics, and health issues through the database hosted by the World Bank Group. In order to decide the winner, we formed a jury from the academic and the industrial worlds. So we want to thank them all. So thank you to Maria Paola Caldas Rivera from Deloitte, Pierre Clogan from AgroParisTech, Sarah Lemler from Centrale Supélec, Christophe Regoubi from Airbus, Angelina Roche from Paris Dauphine, Mohamed Sedki from Paris Sud and INSERM, and Julien Cornebise from Paris Dauphine. So we took into consideration 5 points to evaluate all the submissions. First, of course, the scientific quality of the analysis and the R code. Of course, we need to have good code, meaning like a code with comments, reproducible, and optimized. Finally, we also take into account some originality of the submission and the relevance of the conclusions. So we want to thank all the participants because we had great submissions as well as nice, shiny applications. But of course, we need a winner. So I'm pleased to announce that the first prize is for Gabrielle Deveau from Keynote and her team. So congratulations.
Hello. I just wanted to say thank you to the jury and to my teammates, Philomène and Lucille, who did an amazing job. It was their first internship in a company and their first kind of mission. So thank you to them and to the jury.
So in addition of the free registration, we are glad to offer also an Amazon voucher, and Springer offered 2 books, and Wiley offered also 1 voucher. So thank you to all, and don't hesitate to go online to see her work. Thank you.
So now for the poster prizes. The poster prizes, there are 4 of them, and they were awarded by GDRs, which is a French structures research groups which aim to foster collaboration and scientific research on given topics. So I will let each, the representative of each of these groups explain very shortly what their goal, what their group is about, and then name the winner of the poster. And the prizes of the posters are exactly what Aurore just described, which is so two books by Springer, a voucher for Wiley, and an Amazon voucher. So first, we start with Aurélien Garivier for the Madix GDR.
Thank you, Pierre. So my name is Aurélien Garivier, so I'm here for GDR Madix. So Madix is a research group, so for the French National Research Agency dedicated to data science in a very wide meaning. Its goal is to encourage interdisciplinary collaboration between data producers, data analysts, and field specialists in all sciences involving data. For example, biology, medicine, ecology, astronomy, social science, economy, journalism, and so on. So to achieve this goal, Madix has three main instruments. First, specific support and networking for students. Second, support for the organization of scientific events. And third, mainly actions, which are dedicated, focused on a specific subject, and led by two scientists from different disciplines. Typically, one is a mathematician or a computer scientist, and the other is a biologist or whatever. An action organizes meetings, hackathons, or such events. For example, one action is the EADM, which is dedicated to data mining of acoustic environmental data, so mainly acoustic undersea signals. We have a call for new actions right now. We have lots of news and events. You may want to look at our website, which is indicated here. So we had the very difficult task to choose one among the many fantastic posters presented in this user conference. I was much impressed by a good number of them dedicated to profile visualization, sequential dynamic time warping, flow modeling, or NoSQL database integration in R. But we could choose only one, and so the winner is Gaston. So I'm calling, so Gaston is a flexible R environment function for efficient manipulation and analysis of high-dimensional S&P data. And so I'm calling Claire Dandine-Roulant for her prize. Congratulations.
Thank you very much.
Tu dis un mot sur ton truc? T'es pas obligé. Juste ce que tu peux dire, tu vois ce que...
So I already present my poster. So it's the rare package Gaston. Just for the little history, perhaps Gaston not means nothing. It's just for a name, a French name. So it's for the genetic analysis with quality control steps and analysis for relatability or association, for example. And you have a lot of extension for gene environment studies, for example, etc. So thank you very much.
Oops, no, sorry, wrong order. So the next prize is awarded by the group Mascot NUM. So I guess it's Céline. Yeah.
So hello. So what is Mascot NUM? Well, it's a French group of research also. And what it deals with stochastic methods for the analysis of numerical codes, especially very time-consuming simulations. So the methods, for example, are related to design of experiments, but also to surrogate models like kriging, for example, but also polynomial chaos, and also uncertainty analysis, uncertainty quantification like sensitivity analysis. And various fields of applied mathematics are concerned. statistics, of course, but also probability, computer science, numerical analysis, etc. And many R developments are necessary. And you can, if you check, you can find lots of beautiful R package that have been developed since the beginning of our GDR. So now we had yesterday we saw 13 very, very good posters, but we had to decide. And so the winner is, well, actually, we couldn't decide ourselves. So thanks to the organizers, we decided to give 2 prizes. And so the winners are Andrés López Lopera for his package LINEIC GPR, and our package for Gaussian process regression modeling with linear inequality constraints. And also, the second prize, well, 2 equivalent prizes, of course, is to Céline Monteil for automatic calibration by evolutionary multi-objective algorithm, the Caramel R package. Congratulations. Andrés, Céline.
Well, so thanks. And of course, I want to acknowledge for my colleagues also, Nicolas Lemoine, Fabrice Zawi, and Frédéric Henriks, that works with me with the calibration package. So thanks.
Hi to everyone. I just want to say thank you. It's, yeah.
Hello, everyone. I'm Andrea Rao. I'm standing in for Julie Aubert and Christelle Anniquet-Antier, who could not be here to present this. So I'm representing GDR BIM, which is a research network for bioinformatics and biostatistics. GDR BIM has organized 6 different working groups. So you have a listing there of the different topics that are covered. I'm most familiar with the Statistics for Omics Data group because that's the StatOmic consortium that is federates a large number of statisticians who work in this area. GDR BIM has a long-term partnership with JOBIM, which is a French conference that's centered on topics at the interface of computer science, mathematics, and biology. They also organize a summer school for algorithms and statistics for big data in genomics. And the next edition will be June of next summer. As well as organizing scientific exchanges for young researchers and support for scientific events, among many other actions. So you have the website for GDR BIM on the slide, and the next meeting of the research group is held at the start of November, the 5th through the 8th. So if you're in the Paris area and interested in these topics, you are welcome to join us. So like the other groups, we had a hard time deciding among the 16 posters that were submitted to the bioinformatics and biostatistics topic. But I have the pleasure of announcing the winner that we have chosen, who is Antoine Bichat, for his poster, Impact of Tree Choice and Metagenomics Differential Abundance Studies. Félicitations.
So thank you, and I would like to thank also my PhD advisor, Christophe Framboise, which was here yesterday, Mahendra Mariadasu and Jonathan Placet for their work with me. And yeah, thanks.
And finally, statistics and health.
Good afternoon. I'm Nicolas Savy, in charge of the GDR Statistics and Health.
The objective is to animate and develop the interaction between statistics and health. There are two components in this GDR. First, an executive committee which is responsible of the activities, and a set of correspondents in partnered laboratories which is in charge to disseminate information. The executive committee is 15 members, and the number of partner laboratories is about 40 members. The main action are the sponsorship of scientific event, for example, useR. And the main action is traditional days of GDR, which is now in partnership with the French Society for Biometry and the Biopharma group of the French Society of Statistics. Our next meeting is in Paris in October, and all of you are welcome. No, not of you, because we have to pay the dinner, and it's not possible for us. The last action is a master internship grant between two partner laboratories. So the prize for the best poster, the jury was composed of Philippe Saint-Pierre of Yves Rosenholk. We have chosen two junior posters, and the award is to Paul Bouchquet, Geoffroy Soléac, Damien Leger, using R for automatic sleep analysis as a regular part of the clinical process. Congratulations. Perhaps a song in order to start way to hills. Yeah. Congratulations.
Thank you very much. Thank you very much. It's the result of 2 years' work in the team at the Hôtel Dieu. I would like to thank you, my team, Geoffroy, my colleague, and Damien, our boss, the boss of the lab. Thank you very much. Okay, thanks everyone. So we are ready to move to the next session, which is the keynote session. I just wanted to acknowledge the support of the French Society for Statistics for the Datathon and all these groups of research who not only supported financially the conference, but also had the difficult task to award these poster prizes. Thanks.
Qu'est-ce qu'il y a? D'accord, ok. Eh bien, mettez-le. C'est laquelle là? Tu sais où est-ce qu'elle est? Vas-y, tu y vas. Ok. Tu veux le faire comme ça? L'autre onglet. Oh, it's already. Participant à la réunion, ouais. Participant sur la réunion. Perfect. And then? Maybe you should do it. It was connected. It was open, it's not anymore.
Just here? Okay, sorry. So we're in a tech conference, and of course, what more fun to have than with the audiovisual presentations? Can you start introducing while I just, turn it off and on again?
Sure. All right. Can everybody hear me? All right. So My name is Erin Liddell. I'll be chairing the keynote session today. So this is Julien Cornebise. He's a director of research at Element AI and head of their London office. He is an honorary associate professor at University of College London. Prior to Element AI, Julien joined DeepMind, which was later acquired by Google, as you probably know. He joined there in 2012 as an early employee. So during his 4 years at DeepMind, he led several fundamental research directions used in early demos and fundraising. So he has a bit of an entrepreneurial spirit in him as well, and he helped create and lead the Health Applied Research team. Since leaving DeepMind in 2016, he's also been working with Amnesty International. He holds a master's in computer engineering, another master's in mathematical statistics, and he has a PhD in mathematics, specializing in computational statistics. So he's got it pretty well covered here. So without further ado, I will let you, as long as you're set up. Okay.
No, don't worry, I can start without being set up. I'll be the IT guy, don't worry.
Okay, great.
So, thanks everyone for still being here so late in the week. It's a real honor to be presenting to all of you today. My name is Julien. Thank you very much for the introduction. And I'll shut the computer at the same time, set up Dropbox, nope. So, today I want to talk about AI for good, with quotes, which will become clear in a minute, and more precisely in the ecosystem of R and Python, and a few others just for good measure. By ecosystem, what I do mean there is not only the tools, but also especially the people. Because behind the tools, if you look around you today and throughout this whole week, it's all about who is behind these efforts, who are exchanging the ideas, who are sharing a purpose. The main interest of useR, given its current size, is probably not so much being in the room and watching someone like me speaking, but more importantly, connecting to all the people that you only see possibly once a year. And I know several of you are watching remotely, and well, I hope that for you, you can connect and share at least a little bit of what we're living here. So now that this should be set up, I should be open the right slides and get going. All right. So my background, Leah, thank you very much for presenting roughly what my background is. And with a lollipop, is that on? Yeah. Hello, hello. Nope, it is not. Never mind. So. All right. So indeed, my background, I started as an academic, did my PhD in France, a bunch of postdocs in the US, Canada, and eventually London 10 years ago. Then got hired by the small startup at the time called DeepMind Technologies. I was a fifth researcher. We were 36 employees at the time. It was a fun ride, 4 crazy years. Then moved on to take a sabbatical of 1 year where I started volunteering for Amnesty International and realized, hey, what I'm doing with them is really cool. What could we do with a bigger team? And that's where I built the London office of Element AI, where I've been able to create a fantastic team whose work I'm going to talk about today. So, in more visual terms, this was high school and undergrad, mostly assembly and this kind of thing. So that's to illustrate the kind of bias I might have. And if we can click to remove this, oh well, sorry, you'll be cut out at the bottom. So that's high school. This is a talk you are happy I'm not giving today. This is my postdoc and PhD. And during these years, 2004, 2005, our ecosystem looked very much like that. This is our GUI. I could not find a screenshot from 2004, so that's 2010 that's going to do. Our studio was still not there, and a lot of the lab and my colleagues in pain and PhD studies were painfully copy-pasting from Notepad to our GUI. And I see several of you nodding, traumatic memories, PTSD, full blast, you know where you've been. Now, at the time, and that's where the notion of ecosystem comes in, one of the 2 labs I was at was actually working fully with MATLAB, which for the kind of statistics I was doing at the time, Markov chain Monte Carlo and sequential Monte Carlo, turned out to be much faster for numerical computations. So MATLAB was where I went, while at the same time using R for pretty figures. Well, actually, no, ggplot wasn't still around. So using R mostly to be able to exchange with the colleagues of the other lab. Now, fast forward through the postdocs and to DeepMind. There, I moved a little bit more further away from the equations, started to learn to do pretty drawings, and this is essentially Bayesian deep learning, which is trying to bring some Bayes laws through variational inference to the deep learning craze that was starting all around. The ecosystem for that is an interesting one. At DeepMind, the decision was taken very early on to use Lua. Quick show of hands, how many of you have used Lua? Okay, how many of you have liked it? Sorry, I shouldn't troll on Friday. Lua was a fantastic tool for neural network because of the Torch library. The Torch library is pretty much the only library at the time was able to do deep convolutional neural networks very easily. The problem with Lua is that it is the opposite of R in its philosophy. The motto of Lua is no batteries included, to the point where the maintainer of Lua actually removed some mathematical functions, arguing that they were not needed anymore. So yeah, you were using the inverse cosine hyperbolic. Too bad, not there anymore. Which, again, if you're doing purely neural net, you don't mind. Torch is here, Torch 7 at the time is there, you can use it. Well, it turned out that being a Bayesian by training, I had to need a few random number generators. You know, the uniform number generator, not enough. So I ended up porting a lot of the random number generators from scikit-learn and from SciPy, actually, and NumPy, and poured them, luckily written in C, poured them into Lua, and I felt that was a really good use of my time. Well, more seriously, that's something I needed, and the ecosystem around Lua was not there for this kind of algorithms. Now, at the same time, we had taken the decision to all stick to the same language. Again, to create a mini ecosystem within the company, all 36 of us at the time, to be able to exchange algorithms really easily. This being said, on the side, I was able to use, well, of course, R and RStudio, because for proper visualization at the time, and still now, there's no better thing than R and ggplot. Never underestimate the power in terms of fundraising of a really, really pretty graph. And there, R was extremely helpful to process the huge amount of experiments and outputs of our neural networks. Because yeah, it's very nice to have a shiny neural network and run tons of experiments. If you want to draw any, even empirical understanding out of it, because a lot of deep learning at the moment is made of trial, error, and experimental understanding, you need to be able to churn out all the logs of your experiments. And that's where R absolutely shined. Now, after 2 years within DeepMind in the fundamental research, I moved on to decide, well, can we do some more applied work? And can we use all these cool tools that we are developing and that are playing Atari, and that's very fun, and that's going to help artificial general intelligence in 50 years or 100 years or whenever, what can we do with it now? So I worked in the health research team, helped create it, working especially on the Moorfields collaboration, trying to use a very simple idea, low-hanging fruit, and the theme of low-hanging fruit for applications will come back throughout this talk, try to help doctors triage patients for 3D imaging of the eye, just so that the emergency room is not swamped with patients anymore, that the doctor can actually just find the most important one and focus on them. And this work actually continued after I left, so I spent 2 years working on the health research team, and this has continued with a link with the veterinary affairs that I started there, and actually now products being made out of these first algorithms that we developed. So pretty excited about the impact that goes on. But what excites me most is what I've been doing since then. So I left in 2016, mostly because DeepMind had been a very different environment than when I joined. When I left, and throughout all this project, we had moved from Lua, thank God, to Python in this sense. And again, for ecosystem reason, TensorFlow was being built at Google at the time. And it's no surprise that in engineering, you find many, many more Python coders than Lua coders. So it was time to switch. There were also many more functionalities that were not available in Torch 7, much more maintenance that was going on in TensorFlow, so we made the switch. Most of our work throughout DeepMind, but also especially in the research team and the health research team, was using Colab, which at the time was still private within Google, TensorFlow, Python-based with a Python backend. There were no R bindings at the time for TensorFlow. But also, and I have to confess this scene, I had to do data science in MySQL. There's 2 words for that, never again. Turns out that was the only way we had to access one of the databases, so half we had to do. Now, after I left DeepMind, I started working as a volunteer for Amnesty International. Amnesty International are a fantastic team, and they are doing incredible results and incredible impact with very small resources. I'll tell you more about the Decode Darfur project later on, but this is what the key of the last 3 years. Starting to work with them on detecting destroyed villages in Darfur. Started as a volunteer, realized, hey, there's good impact to be had there. Spent a year while working with them trying to find how to scale up that kind of effort, which is what brought me to help opening the London office of Element AI. Element AI is a Canadian startup. I'll give you more detail on that in a minute. And eventually that led to such impact as we had at the end of 2018, Troll Patrol, again, something I'll go back to. Now, if you look from afar, especially now with piloting this office, my life kind of went from this guy, having a lot of fun with a ton of shiny toys, to feeling more sometimes like a businessman. I'm drawing the line at the suit, but it's definitely worth it because it allowed me to have a fantastic team that is taking things much further than I can. And this is, again, where the ecosystem comes in, is putting people together to go further. Now, precisely modulo the suit part, my comms team would hate me if I did not mention what we do at Element AI, so I hope you'll indulge me. This has been a crazy ride. Element AI, it's a business-to-business software company. It does enterprise software with machine learning and AI. It was co-founded in 2016 by Yoshua Bengio and Jean-François Gagné, Yoshua Bengio of deep learning fame. It's a machine learning horizontal, saying, hey, ML and stats and everything can do a lot of things. Why sticking to one vertical? Let's try and see where we can bring it for every possible company. Not every company can have a research lab of the talent that is required to advance these kind of applications. Let's be that research lab. And let's provide this, turn this research into concrete software. After 6 months, they raised $100 million US, which was historic Series A for Canada, which allowed to go really crazy and hired 500 people over 2 years. This is, I thought DeepMind had grown fast. Element AI was a step below. We know 500 employees, 300 and something in Montreal, 100 in Toronto, and then offices in London, Singapore, and Seoul. Research lab, product team, applied research, and a whole AI for Good department. We are 13. We're based in London and working, most importantly, with the whole company. And again, I'll come back in a few minutes on why we have that there. Okay, AI for Good, that's all very nice. I'm a white male in my 30s, sitting behind a computer in London, wanting to do good. Well, there's a name for that, white savior. And that's very much what I'm trying to avoid. So how do we define good? Well, the first thing is, I don't know for you, I have opinions, sure, about how the world should work or could work, but so does everyone at the pub or at the cafe nearby. The key thing to remember is that technology is not a solution. It is an accelerator. Essentially, you just have a better optimizer with technology. You're just fitting better to the incentives that we have around us as a society, and that as a society we set. So with tech, you're just going to be able to zoom in really quickly to the most optimal setup for the current environment you're in. And that can have terrible problems, as we are seeing with incentives like selling ads and getting people lowering their attention span and getting stuck on several social websites. So this is exactly where we need to be very, very careful. We're only magnifying the human intent and capacity. And if you have not read this book, I highly recommend it, Geek Heresy by Kentaro Toyama. He used to be Mr. ICT 4D, Information and Communication Technologies for Development at Microsoft. There are 30 years of information and communication technologies for development. We have 30 years to learn from. There's been many fiascos, from the one laptop per child initiative, piles and piles of laptops not used in India because, well, you can send a laptop, if no one knows how to use it or don't have electricity, not going to make much good. Telecenters, play pump, if you want to have fun, Google them and you will see how techno solution can really, even with the best intentions, fall really flat. So we can learn from many of these pitfalls. You know, we're not the first one to say, well, let's use our tech to do some good. The first step that I found to go around these pitfalls is really know where my expertise is. I'm a scientist, I'm a techie, I'm a nerd. There are domain experts, people who have spent decades studying the problems of interest and knowing how to have an impact, knowing what actions failed, what actions worked, and essentially learning everything there is to learn about these very complex problems that we find as a species, whether they be human rights, environment, any of the Sustainable Development Goals from the United Nations, 17 of them with 93 different metrics. Let's empower them. We build tools. We can put them in the hands of those who know how to get impact. They don't know how to use that tech. They don't even know what that tech can do for them. That is where it becomes a partnership. That is where it's not, you know, there's this famous XKCD comic. How many of you read XKCD regularly? Yeah, that's my kind of crowd. So you've probably seen this one a few years ago. And this is so true, you know, walking in and saying, well, I'm going to save the day with tech. And, well, turns out this problem is really hard. Yeah, well, everyone knew it. But now we know it because, hey, I tried it with algorithms. So it doesn't work like that. You go in and you find, as I mentioned earlier, the low-hanging fruit. What is the simplest problem that they are facing? Simplest in the sense that you can solve it with your knowledge, your tools, and working together. And then you start with that. And as you do that, something magical happens. Because you start to learn the language, you start to learn yours. It's not take the data and run. It's not a Kaggle competition. Life is not a Kaggle competition. You all know that. If life were a Kaggle competition, we would not have dplyr and tidyr. You work together, and then one day they come to your office and they, oh, every time I come, I see you playing with this weird algorithm of yours, and I've got a problem that sounds like it. Can you help solve it? Or vice versa. You go to their office, and you're like, every time I come see you, you spend so much time stuck on this one thing, but I heard a guy at a conference who had an algorithm like that. Maybe I can adapt it for you. And now you start, once you know each other and you know each other's domain, you start getting to the real interesting application, which can have the higher impact. Every small impact that you start gets you the right and the credit to go to bigger and bigger things. Now, there's a few pitfalls, and that's a slide. I mean, I usually give that slide to a crowd of machine learning researchers, hardcore in deep learning. Given the R community and the multidisciplinarity of this community, none of this will come as a surprise for you. How do you find the concrete impact? You can say, I'm going to try and predict and measure everything I can about the potential impact of my project. And as a scientist, and as a data scientist, it sounds fine. I mean, a metric, I measure. Well, it is really, really hard to measure the impact that you're going to have. I'll show you an example in a few minutes of an impact that we had no idea about. Instead, let's go for batting average. The partner you're going to work with, how often do they get impact? How often do they succeed? 50% of the time compared to someone else who has 10%? Well, I'm going to go with them because on average, we'll have a bigger impact. Not going to work every time, but we'll be better on average when we do successive projects and products together. There's a bias there, there's a problem. We miss the newcomers and the newcoming small teams who have not yet built this track record. So yeah, there's a problem here. Aware of that bias, let's keep our eyes open for it. Next step is get rid of the hype. Yay, AI, deep learning, really exciting. Killer robots, less exciting. We're not there yet. I mean, we know, you know, what's a deep neural network? It's a nonlinear regression, period. A little bit more, you know, more parameters in there, but that's all it is. So remove the hype and focus on what you can actually solve, and also be very clear about what you cannot solve. And this way you can avoid the tech savior. Stand back, I'm going to save the world with AI. Doesn't work like that. So again, avoiding the tech savior, avoiding the white savior, working with the people on the ground, working with the domain experts. Then the right depth of tech. Not everything needs a neural net. I know it's shocking if you've been to NeurIPS, you can't believe it, but that's true. And currently in the community and the ecosystem we live in, there's more and more machine learners, young machine learners who come there. They would have gone to finance a few years ago, and now they're coming to ML because, yeah, that's where the exciting thing happens. But they do not have necessarily the statistical knowledge that we have in this room. And therefore, they will go for the fancy ConvNet when a logistic regression would work. At a workshop in DAX Tool In February, we had someone from Oxfam coming with a problem, trying to match an exchange system amongst farmers and crops in one country of West Africa. And he arrived and said, well, now that I've heard all you talk, I'm not suited for a neural net. I mean, I don't have a lot of data. We can't solve it. I only have 20 farmers and 100 crops. Yeah, that's called an Excel macro, the solution, and overnight he had his matching solution, and he was very happy. Identify the right depths of tech. Which brings the next hard question. Are you here to solve the problem, or are you here for a really cool application of your fantastic new theory and algorithm? Any of you remember the Pima Indian dataset? Yeah, so you might have seen it in a few statistical papers. It was originally a great study looking at evolution of diseases among the Pima Indians, and then it's been used everywhere as, oh, okay, I've got a method in the early 2000s, I've got a method, and I need to illustrate it on real data. Well, I'm going to grab the Pima Indians. There is room for that. And even in a concrete problem, partnering with an NGO or United Nations agencies, yeah, there is room for someone who is an expert of their method and wants to come and help with their method, completely. But we also need people who are in there and ready to get their foot in the mud and get really practical, pragmatic, and solve the problem with whatever solution is adequate. And there's a combination of these two and the ability to bridge between these two that makes a successful project. And finally, plan for sustainability. You know, there's this hackathon syndrome. You do a hackathon, a weekend, great, feels really good. Really good solutions come out of it, and then they stay on GitHub. And we donate them to the community. GitHub, if you look at it on a very, very depressed day like we have in London with rain and everything, GitHub is the biggest cemetery of really good ideas. I mean, luckily that's not only the case, but the idea is how do we take that further? Where do we find the software engineers? Where do we find the designers? How do we get from the solution to a project to a real product that can be used by many, many people? And all of you who have R packages that are being used by thousands of people or millions of people know that feeling that, wow, with my work and just a little bit of extra work to package it, suddenly, instead of giving it just to my colleague, I'm giving it to thousands and thousands of people. This is again a power of the ecosystem. And R is extremely rich in that sense. Now, I promised some concrete examples. So this is the 2017, the year I took as a sabbatical. And this was work with Milena Marin from Amnesty, Micah Farfour from Amnesty, and Daniel Worrell, who was helping on his night, and he was doing his PhD at UCL. He was doing that on his night and weekends, instead of writing on his manuscript. Okay, that didn't work too badly for him. He's now a postdoc with Max Welling in Amsterdam, doing some really cool stuff. But with just, the four of us, and a few thousand volunteers, you'll see in a minute, we worked on this project called Decode Darfur. Quick show of hands. What is this country? Who knows? Yeah, the first one to answer Africa goes out. So this is Sudan. This is Sudan, and as you might have heard, Sudan has been at the center of a really dramatic conflict for the last 15 or 20 years. And it's been in the news, it's come up and down in the news, and Amnesty and many other organizations have tried to bring it to the forefront, get international action. So what is the problem? On the top left here, this is a tukul, T-U-K-U-L. That's a typical hut that you find in this part of Africa. This is straw roof, wood pillars, baked clay, and mud. You find them in the desert, in these little villages surrounded by fences made of straw. The problem is this. This is two Janjaweed, two soldiers coming on horseback or on a jeep, burning part of the village, raping the women, scattering the population to the wind. And what they left behind are these destroyed tukuls, where there is no more roof, there's no more humans. The walls are much smaller. All visual telltales that can be very easy to see from the sky. Why from the sky? Because it's a conflict zone where the borders are closed. Amnesty cannot send people on the ground to see what's happening. They're doing a fantastic job of qualitative study for leaked messages from survivors, smuggled phone calls at the top of a mountain, survivors who emigrated to the nearby country. They've been able to paint a really vivid picture, and they're extremely good at that, like are many other NGOs. They've been trying to get towards quantitative analysis to complement that, and I cannot emphasize this strongly enough, and all of you who've worked in healthcare will know that too. You do not replace the qualitative by the quantitative. You enhance it. You have both the human stories the direct contact with the patient, the direct survivors, and the numbers to show the scale. And NIST has been working on that. And what means of actions do they have? I mean, this is all what I discovered with them. They have an ability to raise international attention and put pressure on international governments just by, well, shouting about the problem until it's really hard to ignore, and they're extremely good at that. And then gathering evidence to be able to show what happened, when it happened, hopefully trace it back to the perpetrators, and get that in front of a court of law at the International Court of Criminal Court or under other such courts. These are some of the two main levers of action that they have. So they had Micah. Micah is a single analyst, satellite imagery analyst. She's fantastic. She has the most intricate visual cortex I've ever seen. I'd like to clone that because she looks at images, satellite images of villages all day long for the last 5 years. She's really an expert at that. But she's only one. So she's been able to label a few thousand square kilometers or a few hundred square kilometers. She's made fantastic reports on Eyes on Darfur, along with, I think, another researcher. And before and after pictures, very vivid, an attack on Jebel Mara, here's what's happened. And that made a lot of noise. But she's only one. In October 2016, when I met Milena for the first time, they were going for crowdsourcing. Very simple. You have Micah write a tutorial to train a full crowd. And crowdsourcing works extremely well for two things. You get the data, of course, but most importantly, you get the attention of the crowd. And that achieves one of the aims of Amnesty International. You get people involved in a much stronger way than just signing yet another petition online. Well, it doesn't take much of a statistician or a machine learner to realize, hey, you've got all this. The same way an expert can train a crowd, we can have the crowd train a neural network. And instead of doing from 100 to a few thousand square kilometers, you can move to the whole continent. Now, how does that look like in practice? This is a tutorial that anyone logging onto the Amnesty website could see. Here's what you're looking for. You're looking for metallic roofs, clustered together, isolated or in groups, with linear features, fences around them. Remember the fences from the previous picture. What you're not looking for is natural, isolated, green stuff. These are trees. There's a few, not much in Sudan, sadly, but they are there. You're not looking for that. And sadly, what you're seeing too much of is this. This is a destroyed village. And there you can see the difference between a structure with a roof and a profound shadow and just the villages raised to the ground. Now, every person who would connect would go onto this website and see this. 600 meters by 200 meters, click where you see a human presence. Because the first challenge is finding the villages. There is no map of Darfur. And that's where the ecosystem strikes again. How do you get good accuracy? The most important part of this image and this interface is not this. It's a little flag here on the right. If you click on that, that takes a snapshot of the image you're looking at, puts it on a forum where Micah, for the first few days, was spending her days and nights answering questions. Oh, should I label this? Should I label that? And then something magic happens. The first labelers, I think there were several thousands of labelers, the first ones learned from Micah and then started to answer the questions of the ones who were joining more recently. And all of a sudden, you have a whole community of graders really specialized to this task and doing a really good job of it. So here is the importance of design for the quality of your data. And it's not experimental design, it's really pure interface design and human experience. Never underestimate that when you're collecting data in that way. Some people spend 70 hours in 1 week on this website. Actually, Milena called them to make sure they were not trapped in a cave with just an iPad. It turned out it was a lady in a wheelchair who felt that, hey, actually now I can contribute. I cannot go march in the street, but I can contribute to this way. What was the framework behind that? Once I got the data, well, what do I do with it? Of course, R Studio to the rescue, with a whole bunch of really helpful tools that all of you know by heart, whether it be Markdown, TidyR, NITR, ggplot2, to generate proper quality assessment of the crowd, proper repeatable reports. This was around 2017. Even a shiny web app to monitor how quickly I was downloading a lot of satellite imagery on 200 different machines, changing IP every 20 minutes for a reason that I should not talk too much about on YouTube. So this is all the R community there helping that part. When it came to actually moving to the neural net, there I had not much choice at the time. I moved to Python, especially because of TensorFlow and Jupyter, and also a bit of Pandas, because the person that I was starting to work with, Daniel, when he joined the project, well, they're Python people. And again, you go where the local ecosystem is. So, okay, we jumped on. I much prefer the Hadleyverse or the Tidyverse to Pandas for many reasons. Wes is doing a fantastic job with Pandas, but hey, I stick to what I learned first, I guess. And that's what we went with in the second half of the project. Just for the pleasure of the nerdy graph, this is the precision and recall of the crowd when compared to 4,000 tiles labeled by Micah, the expert. So you can see that just with the crowd, and it's about 4 voters per tile on average, you got an 85% recall at an 85% precision, which is pretty darn good for a crowd just of pure volunteers who've never seen a satellite image in their life. And of course, that's the kind of statistics and quality analysis that you need to do before you throw a neural net at it. Garbage in, garbage out. You need to do these kind of things, and we have in this room the talent to do just that. I could geek out for a full hour, but I think I only have 15 minutes left on some fun things that happen when you properly bootstrap the data to analyze the effect of the number of graders on the tiles. You know, as statisticians amongst you will have, as I've heard, how many data points do I need? Well, okay, there's one way to know it. You do with a small sample, and then you bootstrap the hell out of it to be able to simulate the different conditions. Conditional bootstrap, so that you have proper confidence intervals on your estimators, which is what I'm plotting here for the estimator of precision and recall, as the number of grader grows. Wow, what is with a CISO here? Well, it's turned out we have a threshold at 0.5. 50% of the voter says there's a human presence, therefore we label this as human. Well, that's 1/2. And the tie-breaking algorithm makes that, or the lack of algorithm, there's a plain thresholding, make it so that whether you are an odd or an even number of grader, you are biasing towards one answer versus the other when you have a tie. And there's a lot of tie. It's a highly imbalanced setup, 95% class imbalance. Therefore, every tie has an effect. And you can play, I mean, if you have a threshold of 1/3 instead of a 1/2, the pseudo-period of this precision recall variation goes to 3. Well, the interesting part, I mean, it's really fun, but what the interesting part is that the recall is more or less constant. Wow, oh, that means we have a bug in the tutorial. That means there's a whole class of examples that the crowd is not used to seeing. So the precision increases up to a point where you can have 7 graders, but okay, we're gonna need to review the tutorial to boom up the recall. All right, without further ado, what did we get? So this is a web interface that I built because an algorithm is cool, but if you don't have a visualization tool for your oops. If you do not have a visualization tool that the domain expert can use, you're never going to do a lot with that. So in green here is the labels from the crowd. They've spotted here the town of Niala. That's one of the few that is on the map. It's a major town in Sudan. And you can see it could be Toulouse, it could be London, it could be anywhere. Metallic roofs, grid-like pattern, a big lake, river in the middle, and even a park. The decoders, volunteers, also identify these kind of fields where there's little huts and false positives. Hey, that's a field with no hut, shouldn't be tagged. Or like here, these are rocks and cups of trees. They also identified, again in green, more slightly peri-urban villages, like here on one of the major road systems in Darfur, so still very dense. This village, well, these are tukuls with straw huts, much fewer metallic roofs, poorer area. Now, okay, we took all that, trained a simple ResNet 50 fine-tuned pre-tuned on ImageNet with heavy data augmentation. We applied it to the whole area. And here in red is every habitation we found back in 2017. So you can see the villages and the safe region next to the villages in the middle of the desert where you do not need to build a house. You can go back for the night. So we find these arid villages in the middle of the desert. We also find these little specks. I mean, what are these? Are they mistakes? We zoom in? No. They are just huts next to what we believe are cattle trails. So they can be for farmers to be closer to the herds. This was 2017 before Facebook started going berserk and releasing tons of maps. The next question is, how well does that apply out of sample? So if we zoom in to Sudan, sorry, no, not to Sudan, 2,000 kilometers south of Sudan to Uganda, and apply the algorithm, well, there it failed. I mean, there's tons of false positive. Well, no, actually, you zoom in, different urbanization patterns. These are clusters of huts all along the network of roads that crisscross the region. So it works out of the sample, it's generalizable, and that's very encouraging. well, videos are nice, good demos, but what are the classification rates? And this is the confusion matrices with the predicted labels and the true label. We are 97% true positive on the true negative, sorry, and 94% true positive. And on the destruction, we are at 90% and 95%. Now, that's great. It's not good enough, and I'll come back in a minute why. This tool did not have impact yet. It's a proof of concept. We'll see in a minute why. Okay, that was great. Two machine learners, 2 domain experts, tons of volunteers, got that done. Awesome. How do we take that further? So that's where I built this team at Element. You're welcome to snapshot this to be able to see their Twitter. And we did this project Troll Patrol last year, studying the abuse against women on Twitter. And that is a great example of unexpected impact. Warning, the next slide is quite disturbing. These are examples of abusive tweets that women are receiving, women politicians and journalists in the UK and the US. This is what is going on Twitter. This is terribly damaging to our democracy. This is damaging to the women themselves in the first place. We need the voice of these women in the political arena. They get this. Diana Bott, Labour MP in the UK, had to take a complete break from actually working and actually doing politics because of such insults. As you can see, it's really, really not nice. Joe Cox is a deputy member of parliament who got stabbed in the street by a loony. So that's the kind of thing that are online. So here we went from machine learning to humans to machine learning. We built a data set with a machine learning pre-filter because there's only 2% of abuse on Twitter. It's way too much, but if you start to label that, you're going to have really high variance in your small class. We used importance sampling to reduce the variance and drive the engagement, gives the labelers more abusive examples to see, so we can have a better resolution on the minority class, while at the same time keeping an unbiased estimate, thanks to importance sampling. Resorted again to human crowdsourcing, data analysis properly done with Bootstrap, quite computationally intensive. Then we trained a deep model on top, more as a cherry on the cake. We had most of our results with the data analysis, but the deep model allowed us to address whether algorithms can solve or not, turns out not, the problem of abuse online. So we showed that best classifier as 50% F1 score, and we win on 1% F1 score over Perspective API from Google, and that is not good enough. This is something that can help empower human experts, train human experts, but tech is not a solution here again. And this was done with a lot of need for a careful and very sensitive topic, so we needed the human expertise. We did a report, we went public on the 18th of December. Long study, demo of the algorithms, proper stat, properly backed, thanks to Bootstrap. We know exactly our confidence intervals, we know which numbers we can rely on and not. So all the study is really solid, methodology published. The ecosystem, the tooling behind it, well, again, we're mostly a Python shop. That's where I found most of the engineers these days. So Python, Jupyter, Pandas, and PyTorch, which is another reason why we went for Python. You can use PyTorch with replicate in R. It can be somewhat fiddly. And we got massive coverage when we went out on the 18th of December last year. I mean, Bloomberg, The Time, MIT Tech Review, Wired, and a few others in this spreadsheet. What happened next? We did not expect that. This is Twitter stock. The 18th of December is here, this little green day, and then minus 16% overnight. What happened? Well, a financial research firm called Citron Research spotted the study and retweeted massively, calling Twitter the Harvey Weinstein of social media. That did scare a few people away. Now, I'm not in the business of ruining tech companies, but this kind of work, with this unexpected impact, translated the real problem into terms that the investors, shareholders, and executives of this company can understand. The director general of, the CEO of Twitter, Jack Dorsey, then met with the Secretary General of Amnesty. The machine learning team at Twitter reached out to us, and since then they've been much more careful about their messaging and trying to engage more about trying to solve these problems. Now, this is something we wouldn't have planned at the beginning, but again, that's the question of the batting average. Amnesty knows how to do this kind of press and this kind of lobbying. So with the proper methods behind it to show the scale, combined with the qualitative research and the testimonies of the women who faced that, we got that impact. Now, I was talking about the lack of impact on Decode Darfur. So remember this map of the different villages and where we found the destructions. Well, one snapshot of Darfur, if you buy the satellite imagery, costs around $4 million. 500,000 square kilometers times $17 per square kilometers with a 50% discount because you're an NGO, we're the image provider, we're nice, only $4 million. Of course, Amnesty does not have that kind of cash lying around, and that's for a single snapshot. And that's the real problem. How do we do a full-scale analysis? What I showed was on Google Maps or Bing data. And this is data that is collated over 10 years and just put together. It's not the way you can do a proper repetitive study. But there are some public satellites out there. Airbus are private, but the European Space Agency has a ton of them. So does NASA. They're free, but they're low resolution. You cannot see the two cools. So comes 2019, the project, the competition on which we topped from the European Space Agency, joint project with Mila, Yoshua Benjo's lab, and with his three colleagues in our team in London on satellite super resolution. Quick show of hands, who is old enough to remember that movie and know where that comes from? Yeah, I'm feeling somewhat lonely, thanks to the 6 of you who know that it's Blade Runner, the original one. You probably know it better under, can you enhance that in CSI? Well, this is very nice. Okay, we can enhance, and that's a TV show. In the real life, you cannot do that because information is not in the single image, obviously. You can fantasize details, but you cannot reconstruct a license plate. You cannot take a satellite image and zoom in if your sensor is just not high resolution. So how do you do that? Well, you do multiple frame super resolution. Take multiple revisit of the satellite over the same area at different times, or even a movie if you record the continuous stream. Now you have different images with different angles, different subpixel alignment, and now you have the information to be able to do super resolution. The European Space Agency organized a competition. We insert with this architecture, fusion of multiple low resolution with a median as reference, different sets of encoding, and then decoding to upsample, and we got a super resolution view. Behind, again, Python shop, using PyTorch, talk about ecosystem. The PyTorch ecosystem is actually much more friendly to experimentation, in my opinion, than TensorFlow. I could go on in the question sessions about that. So Python all under the hood. And that got us to the top spot, Team Rarefin at the top of the public leaderboard. And then when evaluated on the useR dataset, Artbreak, we came second. We're pretty happy because the first team, SuperPeep, is a lab specialized in image processing in Italy. So for a team that's more doing generic AI and ML with the application in mind, we're not unhappy, especially since we are 0.03 behind number 1. So that was a month ago. What does it look like in practice? This is a high resolution, what you're trying to get. This is from Propavi, a vegetation monitoring satellite. And you can see here the crop circles, and you can count the crops and everything. Now, this is a low-resolution version that you have access to every day for free. Much harder to see anything. This is 1 pixel per 300 meters on the left versus 1 pixel per 100 meter on the right. Take several of these low-resolution together, put them through our algorithm, and what you're getting is this super-resolved version. So if I look precisely here, again, on the left, the low-resolution. Good luck counting any crops on that or any kind of yield prediction. On the right, the high resolution available much more rarely. And in the middle, the super resolution, the output of our algorithm. So here you can actually do counting, you can actually see things, just compute it from multiple low resolution versions. This is perfect for agriculture and land management problems. Same thing here on these examples. Again, in the center, the super resolved version. If we zoom in, you've got the low res on the left, the high res on the right. But without ignoring the high res, if you just work on the super resolved version, the output of the fusion of these multiple low resolutions, well, you can start to see the fields. You can actually count the fields. You can even find the roads and the rivers that were not visible on the low resolution on the left. Same thing for water management and limnology. Limnology, I discovered on Wikipedia while making the slides, is a fancy name for within-land water monitoring, rivers. So again, the low resolution, yeah, well, there's a blurb here. I mean, is it a river? Is it dry? How much flow do we have? If you look at the super resolved, now you can see how much water there is. And you can compare it to the high resolution, again, much more rarely available. And you can see that you're really not far off the mark. Now, you can find more detail about this specific problem on this URL or this QR code that you're welcome to snapshot. We just released a blog post about it. Because the idea is to take that further and now enable NGOs to take the cheap low-resolution image and get the work that it would have to pay millions of dollars to do on high-resolution image. But I mentioned ecosystem being humans. You've all seen that. You've all seen these articles about the Facebook employees who are really getting unruly about what's going on in Facebook. That was last year. You see the same at Microsoft. The open letter from the employees say, hey, Microsoft, don't bid for the JEDI contract with the Department of Defense. Microsoft did. You've seen the Google employees doing walkouts. And again, some more walkouts, this time against censorship in China. And then some. For the record, Meredith Whittaker, who is a fantastic researcher at Google who has been leading these walkouts alongside 5 other people, is now facing retribution from Google and is pressured to either leave all her responsibilities in ethics of AI, she has founded AI Now, the think tank, or leave Google. So nice gesture, Google, putting pressure on Meredith for speaking out against the very problems that a company can pose. Now, why do I mention this? I mean, there's this been fantastic report in the New York Times that says it. Well, tech workers, all of us here, we want to know, what are we doing that for again? I mean, what is it going to be used for? That's kind of why I'm starting to go towards, the suit path. Because if no scientist starts going into these management positions, we're leaving it to the MBAs. And with no disrespect to my friends and colleagues who went through MBAs, I think we can do with a little more balance here. But why does that matter to you? There's been this report by some of my colleagues at Element, which studied how many artificial intelligence experts there are, machine learners, computational statisticians. There's a ridiculously low number over the world, and there's a very high demand. Wait, you have a skill that few people have, and the companies really, really want you. Well, that's a perfect position to negotiate and say, hey, I'm going to come work with you if you actually decide to do things in the right way, in a good way. I mean, our studio has been contributing tons of stuff, and some of the best people in the R ecosystem have gone to work with our studio. I mean, that makes a perfect business decision. Makes perfect sense. So, okay, let's steer the companies in that direction. And this is something that you can do by saying, voting with your feet, or arguing internally to your boss, say, hey, I would want to work on this kind of for good project, and it makes sense because it will stimulate our talent, it will allow us to discover things, it will attract great people. There is a way to pitch it in terms that make sense for the business, and at the same time that makes sense for society. So the 3 takeaway message, really. The ecosystem, you are the ecosystem. All of us in this room, everyone working on R, on Python, on anything, we really are this ecosystem. I encourage you all to take your phone right now, open datakind.org, and there will be a line, apply now. Datakind is a website organizing volunteers, pairing them with NGOs, so that on your nights or weekends, or sometimes hackathons, you can help these NGOs with their data problems. Datakind, they're doing a fantastic job. They take several volunteers to pre-filter these projects, prepare the data in a way that can be actually used. They really are doing an amazing job. They just raised $25 million from the Rockefeller Foundation to be able to scale that up. If any one of you is interested in this kind of problem, go to datakind.org and volunteer. That's how I got in touch with Amnesty International. That's what got me started there. I went to this meetup because Datakind was presenting. Oh, well, and there was Amnesty too. So this is the ecosystem you can start going into. And the next step, concretely, is you can argue internally to work on such projects. Yeah, it can be your 20%. It can be your nights and weekends if you can use the compute cluster of the office. It can be, there's many ways. But it will only happen if you actively ask for it. And I really encourage you because, again, we are this ecosystem and we really make the society in which we live in. Thank you very much for your attention. I think we have questions on Slido, I imagine?
Yeah, we should. So just a reminder, if you want to ask a question, you can go to Slido, slido.com, and the code for this event is useR 2019, case insensitive. So there's a few up there already, but if you want to add one now, it would be a great time to do that. All right, so top question. What is your opinion on the apparent contradiction between the need of data science, including servers, electricity bandwidth, and climate change, and what can we do about that?
This is an excellent question. And many of you might have seen the article that was pointing to this neural net that got trained on for the equivalent of $3 billion and the equivalent of, I don't remember how many thousands of cars in CO2 emissions of their whole lifetime for one neural net. This is crazy. And what happened there is you've got really big companies where it's a dream to go for a machine learner because, wow, unlimited computers. I had some friends running experiments on 4,000 TPUs because they can and because it's easy. When we were a small startup at DeepMind before being acquired by Google and we were seeing Google Brain going all out, we were like, yeah, they're using a ton of machines because just they're lazy, they're throwing machines at it. We're going to do it smarter. Well, we got acquired by Google and, you know, they're still doing it very smart, but with a lot of machines. The super resolution problem that I just showed, I did the math with Michael the other day. We spent 500 hours of GPUs. For all the 50 models that we trained throughout the 3 months of the competition, each of them training for 10 hours. So 50 models, 10 hours, 500 hours. In EC2 cost, that's $1,500. That is much, much smaller. Why? Because, well, we can't afford going for completely crazy networks. We've got to be efficient. And this is where there is a real need to be focused. You might also have seen, and if you haven't, I encourage you to Google it, how machine learning can help climate change or fight climate change. Fantastic paper, 97 pages, 600 references, signed by Joshua, Demi, Sandruing, a lot of people looking at solution, problem per problem and potential solution. That is another way to look at it. But you need the two. You need to avoid doing harm before being able to do good.
All right, thank you. Okay, next question. How can we incorporate voluntary work as a data scientist in our daily life in companies, since most people can't be full-time volunteers? You touched on that a little bit already, but maybe you have something else to say.
So, as I mentioned, you can volunteer. So the first thing is you need to find something to do. Luckily, DataCan helps you with that. And the problems, well, sadly, the problems are very numerous. But again, it's all about pitching it in a way that makes sense from a company level so that your boss, who has his own pressures, can make sense. And you can take concrete examples, again, about, well, let's be very cynical here. There's talent attractivity. Yes, you're going to have really good talent if you are known as a shop that does that. And they will want to come and be part of that. There is the culture of the company. In an era where so many companies are getting so much bad rep for the abuse that, well, the current set of incentives have helped them steer toward, if you become known as a company who is more ethical.
Which is on real-world problems. What is your opinion on PhD programs without focus on real-world problems?
So there's really two questions in one. Actually, my PhD work is not so far from my current work, in that when you develop algorithms, yes, it's really fun to do the theorems behind them, but what is fun is actually doing algorithms with an idea on what they're going to be used for. Besides, and most importantly, in the kind of problems we're doing, yes, I said we look at the low-hanging fruit first. But how do you find the low-hanging fruits? You only do that if you have a knowledge of the cutting-edge research to be able to analyze, oh, this problem that was really hard is now within reach. So the research lab that we have at Element is really at the top of the current publishing to be able to know, oh, yeah, I need to know my methodology so I know that this thing is feasible now and that we can jump on it. So that's where there's a direct connection between what I was doing in my PhD and the applied work that I'm doing now. And the high-res-net, as we will see, is pushing the envelope of what is feasible with ConvNets. And this work was done with PhD students and interns and postdocs also at Mila. So there is definitely an aspect of research there. My opinion on PhD programs without focus on real-world problems, actually it's a good opinion. Because if you want to be able to be fluent in the whole set of problems, you need the mathematical backing. I was a computer programmer during my undergrad. I trained in a computer engineering school, small school, specialized in, let's say, IT systems and coding. I did competitive programming. But then I realized, oh, these algorithms are cool. But in the real world, everything is messy. So I probably need to do some probabilities for that. And friends being friends, you know, who says probability says Borel, sigma algebra, and semi-definite measures. And, well, I went through the rabbit hole. But this has armed me to be able to navigate through current papers much more easily than if I had started by only looking at a small practical problem. Now, ideally, you want to do both, and that's what I encourage you to do. Do the fundamental problem, but try to get involved at the same time on applied problems, because that's how you actually get really new ideas.
Okay, so I think we have a theme here, but according to you, what is the moral responsibility of the data scientist?
Well, you are at the front line. As data scientists, when we apply our math, our algorithms, our skills, we immediately see, oh, hold on, I'm handling this data here, but I really shouldn't have access to that. You know, it's our duty to raise this kind of risk. And again, you need to become savvy in saying, well, this risk here, we're getting access to private data, and that poses a business risk for our company, because if this ever leaks, we will have a Cambridge Analytica problem and our stock will fall. You know, you have to frame it in this way, but this is how you can advocate. And of course, as you know, a data scientist having access to data, I mean, you have, in the worst case, a duty, in a way, to become a whistleblower. And we've seen that with many whistleblowers. What have they done? They have leaked data. They have leaked information. I'm not saying, hey, go out and blow the whistle all the time. But I'm saying, as a scientist, as a data scientist, you have a responsibility to be really careful for what you do. Easier said than done. I agree.
Okay, the next one is a comment, not a question, but someone in the audience wanted to thank you for giving your invited grant to the Diversity Scholarship Fund. So thank you.
Well, I'm glad. We need more diversity in the field. No, I mean, really, thanks to the organizer for having this type of grant in the first place.
Yeah, it's brought a lot of people here today, so it's great. Okay, so this is a fun one. So how can we work against AI for bad, quote unquote, specifically government and security related AI projects?
Well, that keeps me up at night, because even what I'm doing as AI for good, super satellites that super resolve everything you do. Yeah, that sounds like a really, really bad movie. And this is what's used in surveillance. So how not only do we fight against AI for bad in general, but how do I avoid what I'm doing in AI for good go towards AI for bad? So that goes back to this notion of technology as an accelerator for the given incentives. I try to put my tech in the hands of those who are fighting to change these incentives. So that's one first way. And then that brings the responsibility, and that goes back to the previous question about the responsibility of the data scientist. Troll Patrol, the study we did with Amnesty, we have not yet released the data set. Why? Because Amnesty, in their wisdom, know that, oh, if we release the data set such as it is without anonymization, it can trigger, hey, a leaderboard of who does the most abuse against women. So instead, we're anonymizing the data set, and Amnesty will release it in I think in a couple of weeks, I think, so that it can be used for research and be somewhat anonymized. No anonymization is perfect, but it raises the barrier to entry. Now, that's one way. It's about the ethical thinking behind what we do. But more generally, ethics, and there was this fantastic post by Anna Bacciarelli from Amnesty. I encourage you to check it out. It was on Medium just a couple of weeks ago. We say, well, ethics are the new whitewashing. There's a new form of self-regulation. I'm a big tech, I've got an ethics committee, and I'm going to self-regulate. No, you need strong regulation, and you need regulation with teeth. GDPR is a great first example. It's not perfect, and it's got a ton of problems, of course, but this kind of regulation is really important to keep big companies in check, but also to bring better business to the companies. Again, putting it in incentives that companies can understand. If your customer sees that you are compliant with all the regulations and that you have all the certification and the standards in place, well, they'll be sure that they are minimizing their risk to have a Cambridge Analytica scandals a few years down the line. So you have an advantage by being really on top of regulation and certifications. We need more of that.
Okay, we probably have time for about one more question. So this is a good one to end on. So is there anything the R community can do to make R more useful for deep learning?
That's an excellent question. Yes and no. I mean, yes in that already R in the 15 years has become so different that all the development tools, the DevTools package, all the life that has been put into all the new fundamental package about proper data manipulation, about proper development workflows, but this is fantastic. Proper reproducibility, this is amazing. And yes, sometimes it can be hard to again follow Hadley into dplyr, ddply, tidy. Okay, which version, which package should I use? Yes, but that's a sign precisely of an ecosystem that just, wow, really, really active and adding tons of new ideas. So in that sense, this kind of development is extremely good to be able to be very healthy. And the number of people we have here at useR is a great testament to that. Should it be more helpful for deep learning? I know there is a TensorFlow wrappers for R now. I mean, I come, as you've seen, and that's why I put my biography up front, is that I have a bias towards being as close to the metal as possible when it makes sense. If you can go for assembly, sure. C, C++. I find PyTorch being really easy to do that. I know that R has come a long way, but I've not experimented with that myself, with things like RCPP to be able to interface directly with C++ to go really fast on certain aspects of processing, with Replicate or Feather to exchange with Python where needed. At the moment, R is doing a fantastic job of statistical analysis, of a variety, an immense variety of statistical analysis that Python can't do. A fantastic visualization. Yes, there is ggplot in Python now, but honestly, it's not at feature compatibility with feature parity with R, and it probably will never be. So if you're interested in deep learning, if you want to start, you can use TensorFlow bindings in R just to dabble a little. And if that, there's Keras actually in R. Keras is really magic click button. It can get you started really easily. So I encourage you to start playing with that. If at some point you can start to becoming deeper into it and want to develop your own modules, you'll have to go in the internals of Keras, which happen to be in Python. But that is fine. You know R. You know a programming language. You, from that, are uniquely placed to use many programming languages for any different tools. I mean, I coded a JavaScript web interface. Ask my colleague Ji Chao, my code is super dirty and she's pulling her hair when she has to make it run. But okay, I was able to develop that. So use the right tool, and for the R community, keep being the source of ideas that you are, and keep bringing the statistical soundness to deep learning. It can be, having packages that analyze the output of deep learning algorithms for robustness, for replicability. Laure and Dennis in our team, along with Thomas Bocquet and a bunch of others in Montreal, did a whole paper at iClear Reproducibility Workshop, which uses R to analyze the output of PyTorch and LuaTorch and a ton of different algorithms precisely for stability. And this is proper statistics, and R is fantastic for that. So that's the way I would see it. Again, I have my own bias. I've been mostly in Python shop for the last few years. I'm sure many people here in the audience are probably more qualified to handle that one than me.
Okay, well, I hope you'll stick around for our closing remarks, but if you could join me in thanking our speaker one last time. Here you go. Thank you.
Thank you. So I guess this is the end. So I will try to make it very short. I hope the conference has been enjoyable for everyone. I just have a few practical information to give. So the first one will probably be the take-home message of this conference. So this is a chocolatine. Okay, and if you want to know. So this is called a pain au chocolat. So pain au chocolat is a bread with a bar of something in chocolate inside. So it has nothing to do with the chocolatine. Okay, so more seriously, half forwards kindly ask you to fill this form. It helps them to keep track on the user participants to help promote the diversity into the R community. So you will also find the link on Twitter. We have already tweeted it, but we will do it again tonight. So please help them. And I will now call Chris Prenner, because he has an announcement to make for useR 2020. And I will even open your slides.
Thank you.
Yes. CTRL-L.
I'm relieved not to have to use the keyboard. Before I get started about useR 2020, I actually want to thank Nathalie and the useR 2019 organizing team. They've done a wonderful job, and we have enormous shoes to fill. We will be filling those shoes in St. Louis, Missouri, next July, from July 7th to the 10th. If you know anything about St. Louis, it's that we have this enormous arch in the middle of the city. And we're very proud of our city's flag, which we've plastered all over hex stickers. If you want one, we still have a few left, and feel free to come down and talk to the organizing team that's here after, and we'll give you one. If you don't know where St. Louis is, we're located basically in the middle of the United States. I put the cities on here basically for context, but also if our international airport does not have a direct flight from your home airport, these are a number of the cities we have connections to many times a day. These are the key people if you have questions, hopes, dreams, complaints, and want to reach out to the organizing team. The 8 of us are the best people to get in touch with. Janine and Edzer are in charge of our scientific program, along with Darren Spiegel, who's here, and he'll be heading the sessions and keynotes, so if you have suggestions, Darren's will be down here afterwards. Angela Lee is going to be putting together a number of geospatial events. This is a major business sector in St. Louis and is a way for us to tie the conference to what's going on in data science in the St. Louis community more generally. And then our colleague Srikanth is in charge of tutorials. I'm in charge of the event stuff. My colleague Jesse Mostapak is in charge of our diversity, equity, and inclusion efforts. And if you have questions about sponsorship, Evan Carey is your contact. Lastly, if you just want to stay in touch with what we're doing, we are on Twitter. And we now have a MailChimp list. I recognize not everyone wants to be on Twitter and get their news there. So if you'd like to just receive a few emails over the next year, you can sign up on MailChimp. Lastly, we just want to thank St. Louis University, who enthusiastically supported our bid. They have provided a lot of logistical support and are our first platinum sponsor. So thank you all very much. I hope you have a wonderful trip home, and we'll hopefully see you next year in St. Louis.
So this is a gift for you. We give it with very much pleasure and good luck. So I have a few upcoming HAR conferences to advertise on in Europe in the upcoming months and next year. So YHAR in Warsaw in September 2019, HURUM in Milan next year and in 2020, and HURUS in Vienna in 2020. So you can take a look at their website or Twitter account that are provided here. And if you are French, you will also have the Rencontre R in Paris next year, and they already have a website, so you can also check it out. So Dai Cook now has a short announcement to make. So Dai, if you can come on stage.
I'm actually substituting for Julie Jossi, who can't be here right now. So these are the things I would like to say. The R community is remarkable because there are many people who believe deeply in the project as a whole, who are involved at different levels. There are a lot of people in the core and CRAN teams and the foundation and beyond these groups in the R community who fundamentally support us all. It's extremely delicate to thank a particular person in public because there are so many that deserve a round of applause. However, we're going to do just that. And we've singled one person out to get a big thank you today. We on the Forwards Task Force of the R Foundation for widening the participation of women in and underrepresented groups would like to thank one instrumental member, Heather Turner. Heather tirelessly and quietly works on diversity development broadly in the community, as well as helping bring the useR conferences to fruition, all the while maintaining her own scientific research. Your fellow Forwards members passed around a hat to collect money to buy you a little gift, which is not tiny at all, actually. And a big thank you to let you know that we adore you and appreciate your contributions. And we also have a few words from Hannah on behalf of the R Ladies and from Laura on Latin R first before I can pass the gift.
All right. So just because you do so much that is not always seen because you're quiet about it, I wanted to highlight two things that you did for Our Ladies. Back at useR 2016 in Stanford, you organized a session on our initiatives and invited the two chapters that were active at the time, San Francisco and London, to come present. And for us, that was the first time we actually met. And the feedback that we got during the conference led to us forming the global organization, which then enabled the rapid growth in the number of chapters that you've seen over the past few years. So that would not have happened without you. And you did not just connect us, but when we applied for a grant from the R Consortium to build out the infrastructure for this endeavor, you helped us with that application and contributed all your knowledge. And I mean, you know that you do all the little things, but I wanted to highlight these 2 points today. So the Our Ladies organization and the community wouldn't be where we are today without your help. So thank you very much, Heather.
I have to read because I want to get this right. Heather has been instrumental in the art community in so many ways that they are difficult to enumerate. Her leadership to make the art community more diverse, inclusive, and safe for everyone is outstanding. An example from Latin America is Heather's guide to Start Latin R, the Latin American conference for the use of R in research and development in 2017. Latin R took place for the first time in Buenos Aires last year and will be in Santiago de Chile in 2019. Latinar helped enormously gathering the art community in the region and is bringing for the first time to our countries art reference like Jenny Bryan, Mine Chetinkaya Rundle, Erin Liddell, or Hadley Wickham. At a more personal level, Heather is always available for everyone and is a source of immense wisdom for both about data analytic and art knowledge, but also about the community. The Latin American community doesn't have enough words to thank her for all her mostly invisible work. Thank you very much, Heather.
I guess I have to say a few words. I'm extremely touched. Yeah. Yeah. So it just makes it all worth it, and thank you so much. I think I can retire now.
Thank you as well from us. You have been a very huge support for us. Okay, so I have a few thanks to make on my own. So first I want to thank Gaëlle, Camille, and Aurélie from the accounting department who have made an amazing job with handling the registration. I also want to thank all the volunteer students, the 23 volunteer students who have helped us in the conference center this week. You were great, thank you. And I want finally to thank the members of the organization committee. Please come with me. Anne, Aurore, Elise. You haven't seen Elise much because she is pregnant, but she's here today. I won't be able to say their names. Rémi, Thibaut, Robert, Sébastien, Pierre, Mathias, Xavier, thank you. That's it. There's the last coffee break in case you haven't tasted enough our pastries and the chocolatine.